All right, so somebody read me number 17, please.
Write a rule for the nth term of the geometric sequence. Then identify the first 6 terms of the sequence.
So we need to write a rule, correct? Right, that's what it tells us. Now, when we write a rule, it said, did it say geometric or arithmetic?
Geometric.
So that means it's in the form a sub n equals a sub 1 times our rate to the n minus 1, right?
Correct.
All right, now they don't give us our rate, so we are going to have to do a little bit to find our rate. And it's not a process that we are unfamiliar with. We've done this process a lot of times. I just don't think we've looked at many examples that are just like this. So when we are looking for our rate, we want to start to write an equation with the information we have. Well, technically we want to write 2 equations. So right here we have that the third term is 16. So we know that 16 equals, we don't know a sub 1, we don't know our rate, but we know that our n value, our position, is the third term. So we can start to write an equation and we can simplify. Now if we want to write an equation, I'll go with a different color. With the information we have here, we can begin to do that. The fifth term Are we good so far?
Yes.
Now, we have 2 equations. We know that they have to equal each other, right? They represent the same geometric series, or sequence, excuse me. So, in the past, and we've done this in other situations, we have taken one of our equations to solve for a variable. So in this case, we'll solve for a sub 1. And then what have we done once we've isolated like a sub 1? We've taken it, and what have we done with the other equation? Yes, Faith? Yep. Yeah, we'd go plug it into our other equation. We divide each side by 16, and that would give us, let's see, I think that would give us 16. Anyone have a calculator? 256 divided by 16? Or 32? Might be 32. Is it 16? And we would find that our rate is 4. Now, how would we quickly find our first term? Like, really quick, really easy, find our first term. What?
4 times 1.
16 divided by, kind of close. So we have that a sub 1, our first term is 16 over r squared. We just found our r value, so we can plug it back in. It does. So if we were trying to write an equation, we have a sub n equals our first term times our rate to the n minus 1. Yes. Yep. If you're plugging it, when you plug in the big ideas, I don't know if they'll let you put the 1 in front, but
Yeah, it does.
it does? Okay. Again, we have done this process in other contexts. I think 2 chapters ago, we did a process very similar to this, and I have shown 1 or 2 examples like this, but it's been a while. Now, that we've seen questions where they give us a sub 3 equals 16, and then they give us the rate, and that is a lot quicker, right? Then we just need to solve for our first term. But when they don't give us the rate, we need to first write 2 equations, and then solve and find the rate. Questions on that? And there will be a question similar, at least one question similar to that tomorrow on the test. All right, there's one very simple concept that we have not talked about yet, but that will show up on the test tomorrow. There are two different types. So far, they say write a rule for, and they give you some type of sequence. That just means that we're trying to write an equation, right? Now, at the end of this chapter, they talk about two different types of rules. What we have been doing so far is technically we've been writing explicit rules so far. All right, that means that we write an equation, and then if I tell you find the 127th term, you can plug 127 into your equation, and we can find what that term is, right? That's what we've been doing so far. That is an explicit rule. Now, a recursive rule, and I'm just showing you, a recursive rule is kind of the worst because it's not extremely helpful, but the notation comes up or could come up on like an SAT, an ACT, even some type of, like on my math certification exam. So if you continue your math career or if you take any of those standardized tests, then you do need to know this idea of a recursive rule. A recursive rule, like it says here in the green, it tells us how a sub n, so how some term is related to the previous term. And the way that we write the previous term is right here with a sub n minus 1. N minus 1, like we've seen, is just our previous term. Right, guys? Okay. So, for example, if we have 4, 6, 8, 10, if that is our sequence, and if we were to write an explicit rule like what we've been doing so far, we would write it in this form. We're really good at that, right? Then we would simplify. If we were to write a recursive rule, we would write it like it said in our definition, in terms of the previous term and then what's happening. So we can see that we are adding 2 each time, right? So when we say a sub n minus 1, that means we're taking the previous term and we are adding 2. And that is how we would write a recursive rule. Have you guys seen notation like that before, or is that totally a new thing? Because it could have come up in algebra a little bit, but might not have. Oh, okay. Now, what you'll see on, well, I'll show you in a second. Questions about that? And there's just a couple, 1 or 2 test questions on it. It's not a big point. It's more something that I just have to show you. Why is this not practical? Why is a recursive rule not practical? Well, they would give you the first term, so to completely write the rule, we'd say a sub 1 is 4, so we start at 4, and then a sub n is the previous term and whatever's happening. But why is it not practical? You can't plug in your calculator, okay. If I told you to find the 127th term, what would you have to do? We can't do that. Well, if I want to find the 127th term, first I need to find the 126th term. So you can't just plug a number in and find exactly what that term is. You always have to find the term before it. So, like I said, it's not very practical because if you want to find the 127th term, you need to find the 126th, which means you have to find 125, 24, and go all the way back.
Why don't you go to the 128th term and get the 127th term?
Because then you still have to go up to 127. You have to get everything leading up to it. So if we look at number 22 in your assignment, does someone want to read the directions to number 22? Nice and loud.
Write the first 6
All right, so for writing the first 6, we know the first term, it tells us, is 7. How do we find the next term? Yeah, we'd put it in. If we want to find the second term, like it says, we take the term before the second term, so 7 plus 11. 7 plus 11 would give us 18. How do we find the third term?
18
Plus 11. Fourth. Fifth. Sixth. And seventh. How many did you find? First 6?
Yeah.
Oh, I put 1 extra. Yes.
Like, I understand this, but can you go into 26 on the big
How about 25? I think 25 is the same type of.
Well, 26 is like, it's different. It has like 2 2s.
Yeah, that's weird.
We'll get to that in a second. But yes, I can at some point. Yep. Questions? Okay, we got 5 minutes till you guys are out. Now, if we go the other way, if we need to write a rule and they tell us to write it in recursive form, the first thing that they ask for, this is number 25, they ask for your first term, which is 9, and then we write our rule. So what is happening between each term here? It's times 2/3. Yep. So if we are writing a rule, we always have this a sub n minus 1 because with recursive, we take the previous term and we tell what is happening to it. Well, it's being multiplied by 2/3. So our first example, we saw an arithmetic sequence, right? We were adding something each time. We also can write a recursive rule with a geometric sequence where we are multiplying. We take the previous term, multiply by 2/3. Previous term, multiply by 2/3. So if there were an open response question and it said write a rule, a recursive rule, I would expect to see you write a sub 1 equals and write what a sub 1 is and then write a sub n. Because you can't find a sub n if you don't know what a sub 1 is. So you need to write them both. Just like the big ideas has you do. Last one, I think. And then we can look at, you said 26? Yeah, after I'm done recording. Someone read 29 for me.
Write an explicit rule for the sequence. A sub 1 equals minus 4. A sub n equals a sub n minus 1 plus 26.
Now it says write an explicit rule.
Does that mean like swear?
Not quite. That's what we've been doing the whole time, right? We've been writing the explicit rule where I can explicitly tell you, put the 127th term in, explicitly, not like in a swearing way, but explicitly like exactly tell you, take the 127th term. What?
You said the word explicit is going to get blocked now.
I probably will, yeah. So we just need to write a regular rule like we've always been doing for this one. So how do we start to do that? What might be a good thing to do first?
We need to know their first term.
We need to know the first term. They gave that to us, so we're on a good start. We know that it adds 26. So we know that it's arithmetic, right? So then we can write our common difference.
Wait, how do we know it's arithmetic?
We know it's arithmetic because it's adding. If it's adding or subtracting, we put it in our arithmetic form. If this was like multiplying by 2, then we would need to make sure we use the geometric equation. So for what? Now, to write it all the way in simplified, we need to distribute, we need to do all that stuff, write it in simplest form. But this would be our starting point. Any questions before you guys take off? General questions? A recursive rule, again, not a very difficult concept. Take the previous term, and we're doing something to it. But we need to know it. We need to know the notation. It's not very practical, so we don't spend a lot of time on it. For you guys that are taking off,